Physics, Part 1. Physics is the study of how the world behaves and how the laws of nature operate. I beg your pardon, please. Accurate measurement is very important in the development of any science, and this is particularly true of physics. Throughout history, as methods of taking measurements have improved, then new ideas have developed of taking measurements. Then new ideas have developed. In general, physicists begin by observing, measuring, and collecting data. These data are then analyzed to discover whether they fit into a pattern. If there is a pattern and this pattern can be used to explain other events, it becomes a theory. If theory predicts events successfully, the theory becomes a law. The process is known as the scientific method. This is our chapter number 1 that we call Physical Quantities and Units. This chapter looks at the enormous range of numbers which are met in physics, the units in which quantities are measured, and how these are expressed. Well, we observe and measure. Then we record our data, our entries, the quantities. We develop a theory on it, and it goes through the process of modifying the theory. It goes through a process of test, analysis, experiment. Then it either gets rejected or gets approved. So we develop a theory, we sometimes modify the theory. When it goes through the process of test, it either gets rejected or gets accepted. This is our block diagram to illustrate the scientific method. So, quantities and units. At the end of this section, we should be able to show an understanding that all physical quantities consist of numerical magnitude and a unit. We can use prefixes and symbols to indicate decimals, submultiples, multiples, submultiples, and multiples of units. We can recall the following base quantities and their units: mass, kilogram; length, meter; time, second; current, ampere; temperature, Kelvin; amount of substance, mole. Well, we can express derived units as products or quotients of the base units and use the units as appropriate. We can use base units to check the homogeneity of physical equations. We can understand the use of convention of labeling graph, axes, and table columns. We can make reasonable estimates of the physical quantities. A physical quantity is a feature of something which can be measured, for example, length, weight, or time of fall. Every physical quantity has a numerical value and a unit. If someone says that they have a waist measurement of 50, they could be very slim or very fast depending on whether the measurement is in centimeters or inches. Take care, it is vital to give the unit of the measurement whenever a quantity is measured or written down.